You press play. Within 2 seconds, your show starts streaming in 4K. No buffering, no lag. You're one of 260 million people doing this simultaneously. Different devices, different countries, different internet speeds. How does Netflix make this look effortless? Most people think Netflix is one giant server somewhere. It's not. Netflix is a distributed system spanning the entire planet, and the architecture behind it breaks every traditional rule of software design. Today we're breaking down Netflix's architecture into 5 critical parts. First, how they split their system into control and data. Second, how they physically move content closer to you. Third, how 700 microservices work together without breaking. Fourth, why they intentionally destroy their own servers. And fifth, how they handle video at a scale that would break normal systems. Let's start with the foundation. Part 1. The split architecture. When you open Netflix, 2 completely separate systems activate, and this separation is the key to everything. The control plane runs on AWS. User accounts, recommendations, billing, what you're allowed to watch, all handled in the cloud. The video itself? That never touches AWS. That's the data plane, and it lives in thousands of servers called Open Connect appliances, sitting inside your ISP's data center. Think of it like ordering a pizza. You call the restaurant, that's AWS, to place your order. But the pizza doesn't come from the restaurant's cloud. It comes from a local distribution hub that's physically close to you. This split means Netflix can scale each part independently. More users? Scale the control plane. More streaming? Scale the data plane. They don't interfere with each other. Which brings us to Part 2. Part 2. Content delivery at the edge. Here's where Netflix does something radical. They ship actual servers to internet service providers. For free. Your ISP gets a box loaded with petabytes of content. The most popular shows, pre-cached, sitting 20 miles from your house instead of 2,000 miles away in a data center. When you press play, you're not hitting some distant server. You're streaming from hardware in your neighborhood. Latency drops from 100 milliseconds to 5. This is why Netflix streams smoothly while other services buffer. They brought the content to you before you even knew you wanted it. But getting content close to users is only half the battle. You still need software that can handle 260 million users without collapsing. That's Part 3. Part 3. Microservices architecture. Netflix doesn't have one application. They have over 700 independent microservices, and each one does exactly one thing. Authentication service, recommendation service, subtitle service, billing service. Any service can fail without taking down the entire platform. One team can deploy updates to the billing service while another team is fixing recommendations. No coordination needed. No waiting. But here's the cost. One button click on your Netflix homepage can trigger requests to 50 different services. That's 50 potential points of failure. So how do they handle all these things breaking? They don't prevent failure. They expect it. Part 4. Chaos engineering. Most companies test their systems by hoping nothing breaks in production. Netflix does the opposite. Netflix intentionally breaks their own systems. In production. During peak hours. They built a tool called Chaos Monkey. It randomly terminates servers. Another tool, Chaos Kong, kills entire AWS regions. Why? Because failures are inevitable at Netflix's scale. Better to find weak points on your terms then discover them when 50 million users are watching Squid Game. Every service is designed assuming everything else will fail. Circuit breakers, fallbacks, retries built into every component. They've tested failure. They've tested infrastructure. But there's one more challenge. Data. Lots of it. Part 5. Data and video at scale. You can't put 260 million user accounts in one database. Even a distributed database would collapse under that load. Netflix uses Cassandra, a NoSQL database designed for writes at massive scale. No single point of failure. Data replicates across multiple data centers automatically. But here's the trade-off. Eventual consistency. If you add a show to your watch list in Tokyo, it might take a few seconds to appear on your account in New York. Most users never notice. For things that must be consistent, like billing, Netflix uses different databases with different guarantees. Right tool for the right job. And then there's video. When Netflix acquires a new show, they don't just upload one file. They create over 1,200 different versions. Different resolutions, different bitrate, optimized for different devices and network conditions. Your phone on 4G gets a different file than your 4K TV on fiber. The player detects your bandwidth in real time and switches between versions midstream. This is why Netflix looks good everywhere. They're not sending you the best quality they have. They're sending you the best quality you can actually play without buffering. Let's bring it all together. Netflix splits control from content. They physically move data to the edge. They embrace microservices, knowing things will break. They intentionally cause chaos to build resilience. And they handle data at a scale that would destroy traditional systems. 3 takeaways. First, architecture isn't just code, it's geography. Netflix wins because they moved the bits closer. Second, at scale, failure is not an edge case, it's the default case. Plan for it. Third, there's no perfect solution. Netflix uses 5 different database technologies because different problems need different tools. The next time your show starts in 2 seconds, you're seeing the result of thousands of servers, hundreds of microservices, and an architecture designed to fail gracefully. That's not magic, that's engineering. If this breakdown helped, don't forget to like and share. Thanks for watching.